Yeah, so this is the answer. But first of all, I guess we need some kind of a question. And why should we matter about analyzing our enterprise architecture? Generally, we see that we connect the things that we have in our organizations more and more to the internet, for example, Internet of Things, big thing. And especially we are doing it with things that were never planned to be connected to the internet, and that's a big issue. So if you look, for example, at the power domain, we are talking about substations built in the 80s for 40, 50 years, and then people want to work from home, of course, and then we connect those things to the internet so that you can access them from home and switch on things and so on. But when we can do it, also the bad people can do it. And the issue is we all rely somehow on electricity and we don't want to sit in the dark. Even some conservatives might like it because then the birth rate in Europe would go up again and might be good for our pension problems that we have. However, so we need to do something. The people are interested in hacking our systems and we need to defend. What we can do is basically reuse the data that we already have in our organizations. And there are different repositories where we could have a look in. And as you know me, maybe, I am in enterprise architecture, and I always had this vision of taking enterprise architecture models and use them for also other things, and for example, to analyze the security parts of it. And Aldina was also interested in it. She was elaborating on trying to find out how resilient an organization is based on the enterprise architecture models. And so we came together and were thinking, yeah, why not combine our ideas and try to analyze enterprise architecture models from a security perspective. Generally, we have big repositories in organizations. So if we talk about enterprise architecture models, those are big, up to 5,000 of nodes. Okay, it's not big data, but they are big, and so big that a single person is not able to understand anymore what's going on there. So that's the one side that we have. On the other side, we have, for example, the CISO, and he wants to know, okay, what applications do I have around, what vulnerabilities do they have, and what's the influence on my organization if something is going wrong there. As those things are so big and enterprise architecture models usually are not designed to be analyzed for security directly, we need to bring in this additional information somehow. And there we face several challenges. How we get this information in there, especially usually, so we have the enterprise architects, they are built, educated in doing what they do, hopefully, but they usually don't have any security knowledge. So taking them as a chance to talk, to add some security information to those models might be not the best idea. Then the other issue that we have is that the enterprise models themselves usually are on some kind of abstraction level because, yeah, okay, models are always abstract. They are encapsulating some information away to make them manageable and serving the purpose that they have. But this also means for us, okay, we could do some kind of security scans or take the names of the elements that we have in our model and go to a database and have a look there, what vulnerabilities are there. However, this doesn't work because in an enterprise architecture model, we might know, okay, there's a Windows XP running, but we don't know the special version of XP which is running there. So we have some gap between reality and what is in our enterprise architecture models. So that's basically what we want to tackle. We defined some kind of objectives that we wanted to solve with our solution. So getting the enterprise architecture models and then doing the analysis. First of all, we wanted to do it automatically. We want to try to get the human out of this equation as far as possible. So we want to have our enterprise architecture model and then in the ideal world, it would be that we do our simulation and we play back this information directly, and if something changes in our enterprise architecture, the analysis can be triggered automatically, so we directly get some kind of report. As I said, I'm personally not a friend of doing things twice, so if we already have some information around, why not using it? So that we wanted to rely on the existing Archimate models in our case, because Archimate is very popular in the research world, and we had some studies some years ago, and they are quite widely used, at least for research purposes where we do some kind of analysis on them. What we didn't want to do, so if you look at the existing literature, there are different extensions to Archimate, especially from our ontology friends, that add some security information to them. But somehow we want to still have some separation of concerns here, so that the enterprise architecture models still have this overall goal of supporting the management in doing their decisions, but not polluting this repository of EA models with additional information which might be too detailed. So therefore we aimed for that we not enrich the Archimate models, but add the information in the processing a little bit later, so that we still have these two worlds, somehow it's separated. And finally, enterprise architecture models, as I said, are about decision making, so somehow it would be nonetheless nice to have the information that we gain from our security analysis back into the models, so that we can get some kind of assessment like, okay, now we have here the applications that are threatening our organization, and then how is this influence on my business processes, for example. And if you know me, you might guess what is now coming. I will talk about attack graphs and the meta-attack language. Basically, what is an attack graph? It defines how an attacker is penetrating a system. You can basically imagine if you are a bad person and you want to steal here the treasure in the room, for example, you have two ways to come in, either through this door or that door. And additionally, for example, if you now look at this door, there might be two locks. And that's then an attack step that we formulate here. And to get through this door, you need to pick both locks, and that's what we call an AND attack step. So because both locks needs to be picked, and that's how we codify it with the ampersand. The alternative that we have are OR attack steps, where you basically just say, okay, you can either go through this door or that door, and then we model this with an OR attack step, and we bring all those stuff together. Additionally, with the hashtag, we have defenses that we can imply. For example, means we have a very good lock employed on our door, and if this is the case, then this certain attack step might not be available to the attacker anymore, because the attacker might not have the knowledge to pick this new lock. And we can do all the stuff, and then we get a big graph, and with this graph you can model the different ways an attacker can do to penetrate a system. Additionally, as I'm coming from KTH, and if you know Pontus, he is in probabilities, we are talking about probability distributions. So we can say a defense is with a certain probability distribution available or not, and that will have then influence on our simulations later on. And we have what we call the time to compromise for attack steps, describing how likely is it for an attacker to be successful to perform a certain step, but also how long it will take the attacker. And then we get some nice probability distributions, and we can make some calculations how long an attacker and how likely the attacker will take through our entire graph and penetrate our system. Now, this is basic knowledge about attack graphs, and now the special thing about the meta-attack language is that we try to codify this security knowledge, how an attacker behaves in our system, and try to hide it for the end user. So we look at our graph and build some assets around those single graphs, describing, for example, what you need to do to penetrate a Windows system or a Linux system. And then we give those to the end user, and the end user just needs to know, okay, I have a Windows machine here, this Windows machine is talking with that Windows machine, draws a line, and in the background, the different attack graphs are combined, and the end user doesn't need to have any knowledge about this. And the nice thing is as well that we can rely on the domain specific terms that they are using. So if you're talking to power people, you can use PLC and RTU and whatever they have. And so they know already what these concepts are that we are using. Okay, now at the KTH and now at SDU, we are developing different languages for different domains, and one language that we have is the so-called Golang, where we basic concepts of the IT domain are codifying. So we have something like data, we have network, we have applications running on systems, and so on. This, as it said, Golang is quite general, and we decided to use this language to have some as a basis for our analysis. So basically we're having our EA models on the one side, then we need to translate them to this Golang language, and based on this we can use tools called SecuriCut, recently got bought by Google, to analyze the system at our hand. So now the big question is, we have our enterprise architecture model in Archimate notation on the one side, and we have the core language on the other side that we can use to do our simulations. How do we bring those worlds together? And what we did in our paper was to suggest some mapping from Archimate concepts to this core language concepts that you see here in the middle. And if you are coming with Archimate, you recognize those are less than 60 elements that we have at the moment in the notation. The first step, what we did, were looking at the different layers that we have, and we're thinking about, is there any element in this layer that we need to map? And in Archimate, for example, we have the business and strategy layer. And looking at those, they are just basic concepts, how you organize the organization and other things around. And the focus of Golang is purely technical. So we don't need to have a look at the processes. So there's no mapping necessarily. The same holds for the implementation and motivation extensions that we have, because they are just on the logical side where we have work packages and stuff, which don't fit to any applications or something that we want to simulate, because the attacker might not be able to penetrate such things. So we ended up with the application, the physical, and the technology layers that were candidates for our mapping. After that, we had a look. So in Archimate, you have active, passive, and behavioral element types. And we just took those active ones as they are described as doing actual things, while behavioral elements are described as that they are using the active structure to realize something. And the passive structures were also not of relevance for us. So that led us to this picture where all those active elements from those three layers are. And then we were thinking about, okay, how do we come now from those different elements to our calling concepts that we have. For the application component, it's quite forward, because we can simply map it to an application. And for data object, I guess it's also obvious why it should be a data. Application collaboration and the interface we didn't consider, because they were not implementing some logic in some behavior in themselves, but just linking back to application components. On the physical layer, we have some kind of equipment, could be robots or whatever. So for us, this is system. System refers to hardware things, and the facility is the area and where we employ our things. So this relates to a physical zone in the calling. And finally, on the technology side, most things are relating to the system, which is the hardware representation, and system software obviously is also some kind of an application, but more on the serving level. Path is then a connection, so we have communication between different applications, and an artifact is just also a data element. Okay, as we had this mapping, we were thinking about how do we demonstrate our approach. And there's this famous example of CAiS'e'22, so you can just download it in the Exchange format and load it to the tool of your choice. And we were thinking, because it's well known, often used also in other research papers, we can try and do an analysis on it. So that's a view from this model. So we took this one, translated it to a GraphML representation. Then, so why? Because we had a tool that was able to translate every GraphML presentation which we have to the format that we need to use for our text simulations. So it's just a step in between. Then we added some additional information to this GraphML by basically looking up vulnerabilities on different systems. For example, you can see over here that we have a web application where the customer is able to perform claims, for example, to the insurance company if something happens. So we assumed there that we have a WordPress running, and therefore, as there was a WordPress, we were able to find some vulnerabilities. We're adding them to the model, and we did the same for other applications that we have in our threat model. Finally, we added here an attacker. So we said the attack surface for the attacker is that the attacker has access to the website, and then we were able to perform our simulations. Monte Carlo simulations run in the SecuriCAD tool, and then we get some results on each and every attack step of each of those boxes. So behind each of those boxes there's an attack graph, and the edges between them describe the possible transitions from one attack graph to the other one. And then we run basically 1,000 Monte Carlo simulations where we see, okay, which path is the attacker taking to get to the interesting things marked with some stars here. We did those simulations and got some results, and then we face a special challenge because we get this information on each attack step, how long an attacker will need to penetrate that one and how likely it is. But as I said, there's beyond each of those boxes, there are large other attack graphs. Now we need to decide, okay, how do we translate this back into our enterprise architecture model to visualize what assets are threatened. And what we did was, we were looking at certain attack steps that are from the language side already marked as that they cause some impact on the asset, and just took those and translated it into some color coding. So when it's dark red, it's really easy for the attacker to get there from the website earlier, and the greener it gets, so unlikelier is it that the attacker gets there. But this is just the first step. Then the next step, where I'm working on at the moment with some other colleagues on, is to reason about what this now means for all the other things. So as you can see, we are just looking at the technical parts of our system, but now the next thing would be to think about, okay, what's now the influence on our services that we have, and what's then the influence on our processes, and what does this mean for our business? Okay, coming to the conclusion, there are different things that you now can criticize what I did, or we did. for the first one, what you can argue about is why using MAL and nothing else. As I said, the nice thing about MAL is that you have this tool support for the simulations, and you have the different plethora of different languages that you can use. So if you're more into industrial control systems, there's a language for this. If you're working on a substation, there's a language for this. And if you have the right models, you can have a nice mapping. The biggest issue that we have right now is that a qualitative analysis is missing. So we have just showcased that it's working, and it would be nice to find some organizations that are willing to give us their models, and we do our simulations, and then we can tell them, this looks bad for you, maybe you want to do there something. That's also then the future work that we plan to do. It's really going to organizations and do what we think it might help them, and investigate also this influence on the business processes and see how it relates all to each other. That's from my side, and I hope for nice questions.
Okay, thank you. Time for questions.
Simon, very good presentation, thank you. I was wondering, what do you mean when you say that, okay, this is easily reachable from the website? Because I mean, I don't understand well if it's just like a reachability analysis that you make from the graph, or what do you consider in this analysis to understand how easy it is to access a particular device or server?
Yeah, so the first step is that we always make some assumptions. What's the attack surface? So what does the attacker has as starting point? For example, just access to the website, or maybe the attacker got some credentials via spear phishing or something. That's then what I mean with easy. In the background, if you we have here our probability distributions, and for each of those boxes that we have some kind of method suggested. It's in the CMIQ journal, where we take some literature reviews and see what vulnerabilities are around, and then we deduct from this some probability distributions describing how much effort an attacker usually spends to, for example, perform a spear phishing attack on a person. And that's then translated and added to the graph, and then we run our simulations and we calculate some averages that then tell, okay, the attacker leading from here, going up to there. We have different distributions that add up, and then we can say, okay, within 90 days, 35% of the attackers are successful.
Thank you. Building a bit further on the last question, if you look at Archimate models, then they do not normally tell you what measures are taken to make logins secure, for instance, whether it's two-phase logins, etc., two-pass logins. You seem not to have taken that into consideration in the sense of, do you expect to add that information to the Archimate models, or do you abstract from it? But if you abstract from it, then you always identify something as red when it's actually not red, because we have a good login system.
Yeah, you're right. That's no information that you have in the Archimate models. But in calling itself, we have some kind of standard defenses. And of course, if we need additional information to set, okay, in our organization, the classical password strength is this, and then you can calculate from it. Usually with a computer, this takes you this 1,000 years to break this password. And so that's one thing that you could do. Like, we have some kind of information about those defenses. And another thing that we did in another project was that we had colleagues from Athens that were developing a tool to assess the security awareness in organizations. And what they did were basically querying the organization and see how aware for different bear phishing attacks, for example, the people are. And what we then did was taking this information from the questionnaires and bringing it into, okay, we don't have here now the human assets, but there are also things about humans in calling. And then we are able to specify for concrete organizations how likely it is to attack via social engineering attack.
And are you also considering looking at the ArchiMate's strategy non-layer layer, where you can talk about things like resources that are strategic resources, and because if you do that, then if you have properly modeled ArchiMate models, you can identify what in your architecture are the key resources. Because there's red, it's nice, but how bad is it that it is red in the sense of the risk?
Yeah, so far not, but that's the part where I was talking here about. So as you see, these are really just the technical parts right now that are colored. And then if we have this information from the strategy things, then we could see, okay, this is an important step for us, and then we can track down to the technical aspects and see.
For instance, the insurance policy data, you probably want to list that as a strategic resource from your strategy there. If that one would turn red, it would be really dark red.
Yeah, that is the next step that we plan for.
I think since people, you can discuss this model at beer later. The chair wanted to ask, this seems to be something like a continuous process a company would have to do. Where in the company this kind of work should reside? Who should do it? What kind of competence do they have? Do they all have to be modelers?
No, so what you need, of course, is the input of this information. And what you could do is, for example, link it in some kind of continuous pipeline thing, where every time we make changes to our enterprise architecture model, the thing is triggered, so that we have on the one side the people making changes to the IT architecture, and on the other side, then there are security people providing the additional information. So this is no job for just one person.
Oh, sure. But the security people should also be a little bit knowledgeable about models and architecture models, which is good for us. We get more.
Yeah, so if you classically look what security what they are doing, if they need to follow the ISO 27001, then they are also forced to maintain the IT architecture, what are the processes, what are the resources. And therefore, I was always thinking, why don't you just take enterprise architecture models where we already have this information? But usually they start from scratch again, because they are just working on their own thing.
All right, so let's conclude this session. Thank you, Simon. Thank you, the other presenters, and thank you, audience.